Hi folks, welcome back to Math with Captain Rod. I'm making this video here to be an introductory video to what I'm going to call the three primary trigonometric functions. So, talk about what we're looking at. So we have a circle here of radius r. Now a lot of books, like the title of the trig book we're using right now says unit circle approach, so they always jump immediately to a circle of radius 1. I don't like to do that because the trigonometric functions apply to all circles of any radius. So we'll look at this in a bit more, in a very general case, and then look at the consequences for a radius of 1 later. But for now, we're going to assume of any circle, any radius. Now, in my picture, here's an angle theta with counterclockwise considered positive. Remember, in mathematics, generally speaking, for all rotational quantities, counterclockwise is generally considered positive. This point right here is just some point on the circle. I'm just going to label it P. Now, this distance along here would be the x-coordinate of P. Here's the y-coordinate of P. Now, before we get talking about the trig functions, let me just make some general observations here. Anytime this point P is in quadrant 1 or 4, x is some positive number. Anytime this point P is in quadrants 2 or 3, x is some negative number. Anytime P is here, x is 0, or if P is here, x is 0. We'll talk about the y-coordinates now. The y-coordinate here of P is positive in quadrants 1 and 2. The y-coordinate is negative in quadrants 3 and 4. And the y-coordinate is 0 here on the x-axis or over here on the minus x-axis. Okay. Now we're going to talk about what are called the trigonometric functions. The ratio of the y-coordinate divided by the radius is referred to as the sine of the angle theta. So sine theta is defined as the ratio of y over r. Now, some things about this. If you look at the picture, y is this height, and r is this distance. Y is always less than r, except at the points here and here, where they're equal in magnitude. So that tells you something about the magnitude of this thing. Y over r is always less than 1 in magnitude. So this ratio, including sines, is bound between minus 1 and 1. Mathematically, we would write it like this. You can't take y over r and get 2 or 3 because the y-coordinate is never bigger than the radius. Some other observations. Since the sine of the angle theta is y over r, this thing is positive whenever y is positive. So sine theta is positive in quadrants 1 and 2. It's negative in quadrants 3 and 4 because the y-coordinate is negative. The sine function has a value of 0 anytime you are here on the circle where the y-coordinate is 0 or here. Another important function, the cosine function. The cosine of the angle theta is defined as the ratio of x over r. So that's this distance, x, divided by r. Similar to the sine function, this thing can't be bigger than 1 because there's no point on this circle where the x-coordinate, again, look at this picture. I'll do this in red. This is the x-coordinate in this picture, and this is the radius. There's nowhere on the circle you can be and have x bigger than the radius. So this thing, again, has to be less than 1. And in fact, just like the sine function, if you include the minus signs, it's bound between minus 1 and 1. The cosine function is positive. Anytime x is positive, that's quadrants 1 and 4. The cosine function is negative. Anytime x is negative, that's quadrants 2 and 3. And the cosine function is 0 anytime x is 0. That's here or here. Okay, and we'll look at some specific angles about that later. Third trigonometric function we're going to talk about, the tangent function. The tangent of the angle theta is defined as the ratio of y over x. Now, first of all, let's talk plus and minuses. The tangent function is positive whenever both of these are positive. So what quadrant would that be? Yeah, that'd be in quadrant 1. The other way this could be positive is if both of these were negative, because a negative over a negative is positive. So which quadrant, what other quadrant would make this thing positive? Yeah, quadrant 3. So this thing's positive in quadrants 1 and 3. And then it's negative in quadrants 2 and 4. This one does not have the numerical restriction that the sine or cosine does, because, you know, imagine when this point is getting up, moving up along here. Y is getting bigger, x is getting smaller, and y is a lot bigger than x. So this thing can get really, really big. In fact, it can get infinitely big. It also takes on zeros anytime y is 0. So that's here or here on this circle. Another big difference between the sine, cosine, and the tangent function is this. These two are defined everywhere. No matter where you are on the circle, you can get values for sine theta and cosine theta. That's not true of the tangent function, however. Remember, you can't divide by 0, so this thing is undefined anytime x is equal to 0. Where in this picture does that occur? Where is x 0 on this picture? Right there, right when we go between quadrant 1 and 2. The actual angle there is 90 degrees, or pi over 2. So the tangent function is not defined there. It's also not defined down here. That angle ends up being 3 pi over 2, or 270 degrees. Or, by the way, any multiple of. So this was meant to be just a quick introductory video of these things. This is how the sine function is defined, the cosine function, and the tangent function. And again, sine is y over r. Cosine is x over r. And tangent is y over x. And one more thing before I end the video about these. They are dimensionless quantities because, you know, if you measure y, x, and r in the same thing, like feet or inches or whatnot, then y over r is dimensionless. X over r dimensionless, and y over x also dimensionless quantities. So, yeah, this is meant to be just an introductory video on these 3 trig functions. I hope that it's successfully done that for you. I'll make others to talk about them in more detail. Have a great day.